we're going to look at inverse functions. And so this is from page 57. The first function that we're going to look at is fx equals x squared minus 5. Now, if you think about what this function looks like, it's a parabola that's been shifted down 5, but this function would not pass the horizontal line test, so it's not 1-to-1. So I'm going to just change this so that way we can talk about the inverse function. And so I'm going to say we're going to look at the function f of x equals x squared minus 5, but we're only going to look at the right side of it, and so that's going to mean we're going to restrict our x's to just be greater than or equal to 0. So that way when we go and we look at the graph of this thing, we're going to have a parabola that's been shifted down 5 spaces and still has that structure, right 1, up 1, but we're not going to go left 1, up 1 because we don't want to go into the negatives. Otherwise, we wouldn't have a 1-to-1 function anymore. And so this is that half of a function that we're talking about. So we're going to go back over here and we want to be able to find the inverse function. And so in order to find the inverse, we can think about how it is the interchange of our x and our y. And so we can actually write the equation and find that f inverse that way. So remember that f of x is really our y. So if we're going to interchange x and y, it'll be x is equal to y squared minus 5. Now we want to work on isolating the y, so we're going to add 5 to both sides. That's undoing that subtraction. So we have that x plus 5 is equal to y squared. Then we want to undo the power 2, which we can undo that by taking a square root. So we're going to take the square root, take the square root, so we end up that y is equal to the square root of x plus 5. And really it should be both the plus and the minus, but because of our earlier restriction here, we're only going to be concerned with the positive output. So we're not going to even worry about that. So we have our inverse function is going to be equal to the square root of x plus 5. Now, another way that we could go through this is by using just the words. So we know that the function f takes an input and squares it. Oopsie, sorry. Then it minuses 5. So if function f does that, and we know that the inverse undoes all those operations, we're going to start with that 5 and we're going to add it back in. And then to undo the squaring, we're going to square root, which this will get us the same inverse function where we take our input, we add 5 to it, and then we square root that whole deal. To graph this function, and so remember that it's the square root function, that's our parent function, but we have moved to the left 5. So if we go back to our graph over here, let's sketch it with some blue. So left 5 would put us here, and then it goes right 1, up 1, and then shoots off. That's our f inverse. Now, if you look at coordinate-wise, what's going on here, our original function had an ordered pair 0, -5, and also 1, -4. Since we're interchanging our x and y's, our inverse function should have the same exact coordinates but reversed. So let's check on that. Oh look, this is -4, up 1, and this guy is -5, 0, which matches up with what we thought. And then just a little reminder that graphically you can see that they are reflecting over the line, the identity function, the line y equals x, which will always happen because of that interchange of our x and our y. Okay, we're gonna go on to number 2, and we look at this function. It says f of x equals x to the third plus 2. Now our cubic functions, or the parent function guides, are these, which are 1 to 1. So we're not gonna put any new restriction or anything to try and make it have a 1 to 1 or a inverse function. So we're just gonna start. We can do it algebraically by interchanging our x and our y. So that would look like x equals y to the third plus 2. And then we're gonna solve for the y. So we're gonna minus the 2 over and be left with x minus 2 equals y to the third. And then if we want to undo the cube, we're going to cube root both sides. So cube root, and so we end up with the cube root of x minus 2 equals y, or in other words, our inverse will be equal to the cube root of x minus 2. So that was algebraically. If we want to think about it using our words, so the other way is to think about what the function f does, and it inputs a number, it cubes, then it adds 2. So then going the reverse way, f inverse has to start over here and say we're going to minus the 2, then we're going to cube root that result. So that would look like f inverse of x equals x minus the 2, cube root that result, which is the same thing that we got algebraically. Those should be the same. Now one extra check that we can do, and I didn't do it on the last one, but we can check their compositions both ways. We can check their compositions both ways and make sure that when we input a value, we get out that same value, because these two functions are undoing each other. And we need to do it f composed with f inverse and then f inverse composed with f. So this is just a little double check. You don't have to do this unless I ask you to. And so remember, the way this works is you're going to take the function f inverse and plug it into f. So this would be f of that cube root x minus 2. And so remember the function f, I'm going to go all the way back up to the beginning here. It cubes and then adds 2. So we're going to take the cubed root of x minus 2, that's our new input. We're going to have to cube this guy and then add 2. And so we can see the cube and the cube root, they undo each other. So we're just left with x minus 2. And then we still have that plus 2 going on. And so those are going to undo, and we'll be left with x as we wanted. We're going to do the same thing going the other way, though, where we take f of x and plug that into f inverse. So we're going to have f inverse of x cubed plus 2. Now remember, f inverse, we're going to go just a little bit up here. This guy cube roots its input minus 2. So what that would look like, we're going to input this x cubed plus 2, but it's going to be minusing a 2 and cube rooting that. So we just stuck x cubed plus 2 in place of that little x. So here we're going to look at that 2 and minus 2 undo each other first, and so we're going to have the cubed root of x cubed, but the cube root undoes the cube, and again we're left with just x. So we're going to go look at the graph of these two things. So our first function was f of x equals x to the third plus 2. So that's our cube root function shifted up 2 spaces. So we're going to be here now. Following the structure, we go right one, up one, left one, down one, and we kind of zigzag that through. And then our inverse function, f inverse of x, was the cube root of x minus 2. That's our cube root function, but this time we're moved to the right 2 spaces. So if we go to the right 2 spaces, do our basic structure, but again, this guy is tilted the other way because cube root doesn't grow as fast. So there's our f inverse. Again, you could double check point wise that they are reflecting over the line y equals x. So just looking at this point, this is 3, 1. And you can see on the graph we have 1, 3. So the x and y's have been interchanged. All right, we got one more function that we're going to graph and find the inverse of. And so this time we have a linear function. It's in the form y equals mx plus b. Again, you can do it either way that you'd like. You can interchange x and y's and solve it algebraically. So we have x equals 1/4 y plus 2, and then we need to solve for this y. So we're going to minus the 2, we have x minus 2 equals 1/4 y. And so if we want to get rid of the 1/4, there's two things you could do. You could divide both sides by 1/4 or multiply by the reciprocal. So I'm going to multiply by that 4, so that way all that cancels out. So we're left with y is equal to 4 times x minus 2, or we could rewrite that as the inverse. And this is perfectly fine, but it's going to be a little bit easier to graph if we actually multiply that out. So for my final answer, I'm going to write f inverse of x is equal to 4x minus 8. It'll be a little bit easier to put on our graph. Now you could also do this with words, knowing that function f takes an input, it multiplies by 1/4, and then it adds 2. So that's what function f does. So then again, we go backwards because f inverse is the reverse. So we're going to minus the 2, and then to undo multiplying by 1/4, really that's dividing by 1/4, but to divide by 1/4 is multiply by 4. And so you'll see we'll get the same exact function as we did right over there. It's going to be x minus the 2 all times the 4. All right, now over here we're going to graph them. So we're looking at the f of x function, which was 1/4 x plus 2. You could do it by slope and y-intercept. Like if you plug a 0 in for x, that ends up being 2. So we know we're at 0, 2. And then the 1/4, that's the rise over run. So you're rising up 1 over 1, 2, 3, 4. Or you can also say it's a vertical shrink by 1/4. So it's only going to the right one space up a quarter, but it's still going to get you this same line. So this is our function f of x. Now our inverse function, let's write that down over here. Our inverse function was 4x minus 8. So its y-intercept going all the way down here, 0, negative 8. And it's going to rise up 4, 1, 2, 3, 4 over 1. Or you could say it's a vertical stretch by 4, which we think about that, right? 1, and we're 4 times as big now. And so this is going to be something like that. And that's our inverse. And we can see it's a reflection over the identity or the line y equals x. And we also can double check a couple points like 0, 2, which is right here. It's if you switch x and y is to 0, which is on the inverse graph. So it looks like it's checking okay. Not going to check with composition. You could try that though. Okay, so flipping the page, it just gives us a couple opportunities to try and verify that these following functions are inverses, but it wants us to use that composition. So we're going to look at f composed with f inverse of x and make sure that we just get x back, and then we want to also go the other way, f inverse of f of x, and again make sure that we get x. So let's try the first way, f composed with f inverse of x. And so that wants us to look here at the inverse and plug that into f. So that's really looking at f of 4x plus 16. And so the function f, if we look back up here, it's going to take our input, multiply it by 1/4, and then you're going to put that with negative 4. So we're going to look at 4x plus 16 going right in place of that x. So I'm going to keep the 1/4 right in the front of it, and I'm going to put negative 4 plus. So then when we go to simplify this guy, the 1/4, once you distribute it, it's going to end up being just x plus 4. Since 1/4 times 4, those cancel, and then 1/4 times 16 is really divide by 4. And we still have that negative 4 going on. And so negative 4 plus 4, we get 0, which leaves us just x. Then we're going to go the other way, f inverse composed with f of x, but again, that means that, oopsie, we're going to be looking at f of x and plugging that into f inverse. So really that's f inverse of -4 plus 1/4 x. So we're going to go up to our inverse function and input this expression into x. So what that will look like, we're going to have -4 plus 1/4 x. We got to take 4 times our new input, and then we're going to add 16. So if we distribute the 4 through, we're going to end up with -16 plus the 4 and the 1/4. Those become 1. So let's have x plus 16. The -16 and 16 cancel, and we just get x. So that shows that they are indeed inverses. Okay, we're going to do the same thing again. This time we have our function g inverse. They look a little crazy because they have some fractions going on, but that's not too bad. Let's start again. We're going to plug the inverse into the original function, and then we're also going to plug, well, hold on. We're going to plug the g function into the inverse. So we got to check both those things. So when we check the first guy, the inverse plugged into g, our inverse is 1 over x plus 1. So we're going to plug that into g. And function g, looking straight up here, says that we're going to take 1 over, here's our input there, minus 1. So on the bottom, the ones will cancel each other out. So we have 1 over x, but that's just 1 times x over 1. When you divide by a fraction, it's multiplying by its reciprocal. So we just get x. On the other side, we're going to take g, plug that into g inverse. So that'll look like g inverse of 1 over x minus 1. And again, we go up to g inverse and see what it does to an input. So it's going to put 1 over that input and then add 1 to it. So our input is 1 over x minus 1. So when we have, again, a fraction over another fraction, we're going to multiply by the reciprocal. So that's going to be 1 times x minus 1 over 1 plus 1. But that's just x minus 1 plus 1. The ones will cancel out. Again, we're just left with x. Okay, we have one more left to check. Again, we were going to still show the same thing, that the composition of a function and its inverse, when you input a value, you get that value back out. That's just showing that the functions are really undoing each other for all inputs. So we're going to start with plugging the inverse into function h. And so our inverse is -3 plus cube root of x plus 4. Plugging that into function h. So again, this is our input. We're looking at function h. That's where our input should go. So we have -3 plus the cube root of x plus 4. We have to cube that, and then minus 4. And I just realized I left out the plus 3, so hold on 1 second. Let's go back over here before we put that on there. So again, our function adds 3 to its inputs before it cubes, so I need to still put plus 3. We're going to cube and then minus 4. So now that means the -3 and the 3, those will cancel out. We're going to lay left with the cube root of x plus 4, which will cube that, and then minus 4. The cube and the cube root and the cube root and the cube undo each other. So we're going to be left with just x plus 4 minus 4, which equals x as we wanted. And then on the other side, if we plug the function h into h inverse, that's going to be h inverse of our function h is x plus 3 cubed minus 4. And so h inverse takes an input, adds 4, and then does the other operations. So that's going to look like x plus 3 cubed minus 4. That's our input. We add 4 to it, cube root that, and then we add the -3. So if we look inside the cube root, the minus 4 and plus 4, those undo each other. So we have negative 3 plus the cube root of x plus 3 cubed, which again, the cube and the cube root undo each other. So we're going to have a negative 3 plus x plus 3. The negative 3 and 3 undo each other, so we're just left with x as desired. So we know that those two functions are in fact inverses.